Today we're going to talk about the converse of the Pythagorean theorem. So basically the Pythagorean theorem says for all right triangles, a squared plus b squared equals c squared. So the converse, when we talk about math and converses, it's basically saying when we take the end and we can replace it with the front. So if I'm looking at the Pythagorean theorem, it basically starts out saying for right triangles, and then it goes on to the theorem. The converse basically says if a squared plus b squared equals c squared works, then we know that it is a right triangle. Now, not all converses would work. As you can see in this upper part, basically what it does is it's basically taking the statement, if P then Q, you should be able to flip it around Q then P. So what we've done is we've taken the right triangles and flipped it with the a squared plus b squared equals c squared, and it still works. Doesn't always happen that way, but it does in this case, and that's something that we can definitely use when we're trying to solve problems with the Pythagorean theorem and sides of a right triangle. So here's how this plays out. So we have a triangle. Now we have three sides. And now we can say, if I use my Pythagorean theorem, I can prove if the angle that we see right here, which looks like a right angle, is an actual right angle, or maybe it's 91 degrees, or maybe it's 89 degrees. We don't know because we don't see that little box there saying that it's 90 degrees. But what we can do is we can use the converse. So basically the converse is saying if I have a squared plus b squared equals c squared, then I can prove that that is a right triangle or it isn't. So a couple of things. We need to remember that the c is always the one across from the right angle. So this would be the right angle in the lower left corner if it was a right angle. Then the a and the b's we've said don't matter. So we're going to fill in the formula and see if this works out. So the question we have right now is, are these things going to give us a right triangle? Well, order of operations, 9 squared is 81, 40 squared would be 1600, and 41 squared with a calculator is 1681. Order of operations again, 1681 equals 1681. So if the left side equals the right side, the equation works, then yes, this is a right triangle. So because Pythagorean theorem works when we have the three sides, then we also know that it is a right triangle. Looking at the second example. Now again, I use the idea that the right triangle is pretty definitely going to be that lower left-hand one. It does appear that the right angle, if this was a right angle, would be about here. We don't think it'll be here. We don't think it'll be here. You also don't want to assume which one would be the right angle. We don't want to assume that this one is not, just because it doesn't look like it, because most drawings are not drawn to scale. But we still just use the converse. If I use the converse, I would say 18 squared plus 12 squared equals 24 squared. Now the other way that I know that the 24 would have to be the hypotenuse is because it's the longest side. So even if I'm not 100% sure, or if they don't show me a picture, if they just give me three numbers, I always know that the C has to be the longest side, so that would be the one by itself. So again, we just got to see if this formula actually plays out and if it actually works. So looking at 18 squared, that gives me 324. 12 squared is 144. And 24 squared is 576. Now if I put together the two on the other side, I get 468 which is not 576. That symbol there is the not equal to. So no, not a right triangle. Now, it is a triangle for sure, but using the converse, we know that this is not a right triangle. So next we want to say, given some points, is this a right triangle? So obviously we need to plot those points first and get a feel for what they look like. Obviously you should be using a straight edge, which is better than my straight edge. Yikes, that's terrible. And I get A is here, B, 3, 5 is here, and 1, 2, 3, 0 is here. So here is the triangle that we're looking at. And the question is this a right triangle? Again, we don't want to make any assumptions that it is or it isn't. So we want to just look at how do I determine what these different sides are. So this one's a little bit trickier because I don't know some of these sides yet. I'm going to have to use the Pythagorean theorem to find them first. So here is AB. And then here's the C. So to find side AB, I'm going to make a right triangle off of this to find out what is this side that's the diagonal. So to find AB, I'm going to use the Pythagorean theorem. So one of my sides, if I go straight up in the air, is 1, 2, 3, 4. The other side off this right angle is 2. So I would have 4 squared plus 2 squared equals C squared. So I would have 16 plus 4 equals C squared. 20 equals C squared. We take the square root. Now, I'm not going to change this into any kind of a decimal. I'm just going to leave this as the square root of 20. So the side over here is the square root of 20. Now let's focus on AC. So AC down here, again, we don't know what that is by counting. We do know there's a right angle if I was to create a right triangle by coming down 1 and then going left onto the right 2. So my side AC is going to be 1 squared plus 2 squared, and that's going to find that diagonal that we don't know. Okay, so 1 squared is 1, 2 squared is 4, C squared, 5 equals C squared. I'm going to take the square root to get C equals the square root of 5. And again, I'm just going to leave the square root symbol there. Now, BC, we know. We can figure out what that one is because I can just count 1, 2, 3, 4, 5. If I'm going completely straight up vertically or left or right horizontally, I can just count the numbers. So I know that BC is 5. So once I know the 3 sides, now I can use that converse to say, is this a right triangle? So I'm going to plug in my numbers. So the side AB, let's see, is 20, the square root of 20, squared, right? Because now we're plugging it into the Pythagorean theorem. The side AC, we said, was the square root of 5, but the formula says to square it. And then C is 5 squared. So here's what we to think about when we did our square roots and squares. The square root of 20 squared means it's the square root of 20 times the square root of 20. So the square root of 20 times the square root of 20 just becomes 20. The square root of 5 times the square root of 5, which is square root of 5 squared, just becomes 5. Remember, they undo each other. So the square and the square root undo each other, leaving us with that radicand, the thing underneath, which is the 20 and the 5. And then we know that 5 squared is 25. So look at what we get. We get 25 equals 25. So yes, it is a right triangle. So a bunch of steps there, but nothing that was really that challenging. Just got to kind of piece together your steps a little at a time as you go. Lastly, we have a real life problem here. We're talking about a football play in which a player runs down the field. So the player starts here at the snap, runs down the field, makes a cut or a turn, and runs to the back of the end zone to receive the pass. Okay, so we want to know, the play says that they should make a 90-degree turn to get to the end zone, which would be the most efficient way to get there. Okay, we want to know if they actually did run that play. So a lot of word problems, the best thing you should do is think about drawing out a play. So we drew out the triangle to see the path of the runner, the path of the ball that's being thrown. It's easier to see it in a visual. So lots of times when you start seeing problems out here in the world with Pythagorean, the best thing to do is try to draw a picture of what you're seeing to see if you can see a 90-degree triangle to use your Pythagorean. So we have to do a bunch of work on this one. It's kind of similar to this previous one, a little bit more involved here. So first, let's find the different D1, D2, and D3. Those are the sides of the triangle. We'll deal with that first. So D1. So kind of like we just did, we're going to form a triangle. So if I was to make a right triangle, I'm coming up 1, 2, 3 boxes. Now remember, 3 boxes is really not 3. In this case, you can see that it's by tens. Okay? So that means that side is 30, and we're going to square it because of the Pythagorean theorem. And if I was to go this way, 1, 2, 3, we now have that right triangle. That's another 30 squared. And that's going to give me that D1 squared. That's the side we need. So 30 squared is 900. Another 30 squared is 900. And that's going to give me 1800 D1 squared. Take the square root. And again, just like on the previous one, we know that D1 is the square root of 1800. We're not going to turn into an ugly decimal. Let's then focus on D2. So D2, 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So if I go down 50 and then over 50, I'll create that right triangle for D2. So D2 would be 50 squared plus 50 squared equals c squared. That is 2500. So I get 5,000 equals c squared. And when I take the square root, I'm going to get the square root of 5,000 equals c. And again, we'll leave it just like that for now. And then lastly, we need this D3. So from D3, I'm going to create another right triangle because I can't count that. I would go over 2, which is 20, and I'm going to come down 1, 2, 3, 4, 5, 6, 7, 8, which is 80. So for D3, 20 squared plus 80 squared equals c squared. So then I'm going to get 400 plus 6,400 equals c squared, which is 6,800 equals c squared. And when I take the square root, c equals the square root of 6,800. So now we have our 3 sides. And we need to now use our Pythagorean theorem and the converse of the Pythagorean theorem to determine if this is a right triangle and if he made a 90-degree turn. So which one, if, excuse me, if I am going to be putting this into the Pythagorean theorem, is the longest side? Because that's what I need to know. I need to know which one is the C. Well, the 6,800 is bigger than the 5,000, is bigger than the 1,800. So when I go to plug this formula in, I need to remember that. So the 1,800 would either be the A or the B. The 5,000 is the other A or B. I square both of those. And then they would have to equal this 6,800 squared. So again, you can use a calculator if you really need to, but you're going to have to be copying down a bunch of decimals and trying to figure out stuff. But here's the best way to do this. The opposite operation, or the inverse operation of squaring, is square rooting. So looking at the first one, when I take the square root of 1,800 and square it, what do I get? Well, hopefully you're saying 1,800. When I take the square root of 5,000 and square it, I get 5,000. They undo each other. So that means I get 6,800 on the right-hand side. And when I add these last two numbers over here, and I think the big thing on this is if you can keep that in mind, that the inverse of squaring is square rooting is going to undo each other, you don't even need a calculator on this one. So to answer this question, he did run the play correctly. So the Pythagorean theorem is a big one. You're going to use that one quite a bit through a lot of your math classes. Looking at the sides of right triangles, this converse is going to be very helpful when you're trying to figure out if something is a right triangle to maybe use for something else. So hopefully it works out. It does seem confusing at times. You're going to be using a calculator for some of it, but see if you can use this converse to help determine whether things are right triangles or not. Again, don't use your eyeballs to determine it. You have to prove it to show that there's a right angle in it. And if you use the formula correctly, you can prove that it is definitely or it is definitely not. Hope this works out well. Let me know if you have any kind of questions.